Hello, and welcome to Technology Today for August 18th, 2024. It's Season 1, Episode 24. I am Mayor Watt, and that is the visualizer and the voice of the sentient AI.
Good evening, hometown citizens, and welcome to Technology Today.
Today we're going to be talking about a parasite brain day. I messed it up right at the beginning. Parasite brain dash delivery, a new service. Whale synchronization, solar farms, hearing temperature, smallest disco party, biggest mystery about plate tectonics, the better strawberry, how breast cancer spreads, the coolest place in the ISS, and the origin of extinction. Everything's powered by ohmtown.com. Go over, become a citizen. But also follow us here on Twitch and over on YouTube. Leave a review wherever you can. Download the podcast. Join the Discord. Definitely like and subscribe over on YouTube, though. That's what helps. That's what moves us around on the algorithm. And we need the help. So, thanks. So welcome back. Let's get into today's articles. The very first one is one that we talked about earlier this week. But this, I wanted to talk about it in Technology Today because I thought that it was really interesting. And since not everybody watches every day, some people are interested in only the tech news specifically. So I decided to grab this one. This is the only one that's pulled from the rest of the week. So a common parasite could deliver drugs to the brain. How scientists are turning Toxoplasma gondii from the foe into friend. And basically, this is a parasite that has the ability to pass through the blood-brain barrier and take with it medications if it is so designed.
Sounds like a good thing. Scary, too.
Yeah, so in Star Trek, there's this bug that they put in the ear, and it takes over your brain and makes you do bad things. And that's kind of how I see this as the progenitor of that, because they're all in the future. Well, Bill Sullivan over at The Conversation put this article together, and to me, this looks like the ghosts from Pac-Man.
Well, at least that seems kind of non-threatening.
But this is Toxoplasma gondii. It's a parasite. And a new study published in Nature Microbiology, they've pioneered... Oh, I'm getting all caught up in the game. They've pioneered the use of a single-celled parasite, Toxoplasma gondii, to inject therapeutic proteins into the brain cells in particular. The brain is very picky about what it lets in, including many drugs, which limits treatment options for neurological conditions. Pardon me one second.
So, I mean, this seems like it could have multiple applications, but as we know, things tend to mutate sometimes or have unintended consequences.
Yeah, so if you have this strange urge to eat grilled cheese, it could be Toxoplasma gondii. Actually, no, just kidding. And I shouldn't joke about it, because when I tell jokes, they usually come true. So a professor at microbiology, they've dedicated their career to finding ways to kill dangerous parasites such as Toxoplasma. They're fascinated by the prospect that it may be used. They may be able to use their weaponry to instead treat other maladies. Ever since scientists realized the microscopic organisms can cause illness, what's called the 19th century germ theory of disease, humanity has been on a quest to keep infectious agents out of our bodies. Many people our understandable aversion to germs may make the idea of adapting these microbial adversaries for therapeutic purposes seem counterintuitive. And it is if you don't know how to control them. Largely, I think that we are guessing.
Well, we don't know a lot. Like we might study something and go, okay, we're observing and doing something, but do we really know the full range of what it does or can do?
Yep. And we find out like 5 years later that, drinking a glass of wine every day is probably not a good thing. But for many years, 15 years ago, it was great. So pills offer a convenient and effective way to get medicine into the body. Chemical drugs such as aspirin and penicillin are small and easily absorbed from the gut into the bloodstream. Biologic drugs such as insulin and semaglutide, on the other hand, are large and complex molecules that are vulnerable to breaking down in the stomach before they can be absorbed. They are also too big to pass through the intestinal wall into the bloodstream. All drugs, especially biologics, have great difficulty penetrating the brain due to the blood-brain barrier, which is what I mentioned at the very beginning. The blood-brain barrier is a layer of cells lining the brain's blood vessels that act like a gatekeeper to block germs and other unwanted substances from gaining access to neurons. Well, toxoplasmosis in otherwise healthy people produces only mild symptoms but can be serious in immunocompromised people. Unlike other pathogens, toxoplasma can cross that blood-brain barrier and invade brain cells. Once inside neurons, the parasite releases a suite of proteins that alter gene expression in its host, which may be the factor in behavioral changes it causes in infected animals and people. In fact, cats and mice and other animals that get infected with this actually they seek being predated upon so that the parasite can actually be transferred to the other entity,
Which is
survival
really astounding, right? Like it's so anti
survival
biology. Yeah.
So they talk about this while like infection can occur in multiple ways, including ingesting spores released in the stool of infected cats or consuming contaminated meat or water, which is why they, if you are immunocompromised or you have what might be a risky, what do you call it? Pregnancy, a risky pregnancy.
Right. You're not supposed to go near cat litter boxes.
Yeah. And so, but if you modify this parasite, genetic modification, then it says here, the team genetically engineered Toxoplasma to make a hybrid protein, fusing one of its secreted proteins to a protein called MECP2, which regulates gene activity in the brain, in effect giving the MECP2 a piggyback ride into neurons. It was too big to make it there on its own. So use this parasite. Researchers found that the parasite secreted the MECP2 protein hybrid into neurons grown in a petri dish, as well as the brains of infected mice. So they did this to treat a rare brain development disorder called Rett syndrome, and the gene therapy trials using viruses to develop or to deliver MECP2 protein to treat Rett are underway. This gave me the idea of what we were talking about in a previous show, where they wanted to reactivate neuron synapse, the axons. They want to actually amplify the connections between neurons, but they don't know of a way to actually get the medication to that area.
Right.
This could be that way, because they could just modify the protein, and then when the parasite is out there exuding basically the trigger for the neuron to send out its tendrils to seek other connections, and it was to treat Down syndrome and other issues.
I mean, that would be really amazing if that could be done here, or with this discovery.
Yep, and it's all about neurological problems, which we are just barely touching the tip of the iceberg. We don't even see the iceberg. It's so underwater. But we will eventually come to understand the brain. It says here up to 1/3 of people worldwide carry toxoplasma in their brain. Apparently, without incident, emerging studies have correlated infection with increased risk of schizophrenia, rage disorder, recklessness, hinting that the quiet infection may be predisposing some people to serious neurological problems. And based on some of the things that I see in the world today, maybe it's true. Let's move on. Next article. Over in Technology Today, scientists uncover mysterious long-distance whale synchronization.
This is interesting.
Yeah, so scientists applied chaos theory to the movement of iconic Arctic whales and uncovered a 24-hour diving cycle and a long-range synchronization. What does that actually mean? What's really fascinating about this is that they attach these trackers, long-term trackers to them, and they're like a blister. They're stuck on there, and it's called a blister, where you basically like super glue something to the side of a boat, so that you can smuggle it in. And that's what they're doing with these little antenna. They stick it on these whales, and it allows the researchers to listen in on their whale song and to track them wherever they're going. It's pretty cool. Hokkaido University put this article together, and it's over at scitechdaily.com. A recent study reveals intricate patterns in, I think it's bowhead whale behavior, indicating a 24-hour cycle of deep diving and synchronization with prey movement during spring. Scientists uncovered this pattern using chaos theory and also observed two whales coordinating their dives over long distances, suggesting a complex social structure and possible acoustic communication among these Arctic giants. Sound familiar?
Yeah, it does.
So, like I've been saying for years, that there is this very low frequency, long distance communication with animals, not just whales, but other animals. We just have yet to actually have the propensity and the technology to just plop it in place and monitor for these low frequency signals.
This would just be really interesting to really be able to decipher this. And of course, if we can find this in whales, what else is doing this?
Yep. So now in a paper to be published in the journal Physical Review Research, a team of scientists from Japan, Greenland, and Denmark have detected patterns in the whale's behavior that could offer clues into how they forage and socialize. The associate professor Evgeny, I guess, A. Podolskaya, at the Arctic Research Center, Hokkaido University, Professor Jonas Thielman at the Department of Ecoscience, Aarhus University, and Professor Mads Peter Heide Jorgensen, or I tried. Anyway.
This was a long passage with a lot of names.
Yeah. At the Department of Birds and Mammals. That went from very complex to pretty straightforward real quick. It's like from 60 to 0 to 60. Anyway, Greenland Institute of Natural Resources studied 144 days of diving records of 12 bowhead whales tagged in Disco Bay, West Greenland. Because the whale diving behavior can be seen as a chaotic, self-sustained oscillation that balances the need for food at depths with the need for oxygen at the surface, the researchers used a dynamical systems chaos approach to uncover patterns within the apparently disorderly collective behavior.
I wonder if they used AI.
Well, yeah. So we find that foraging whales dive deeper during the daytime in spring, with this diving behavior being in apparent synchrony with their vertically migrating prey, said Heide Jorgensen. Until now, this hasn't been shown for spring and remained contradictory for autumn. So I guess when their prey is going higher, they go deeper, I guess, to catch them in the angle of attack, I suppose.
Yeah, or maybe sneak up underneath them? I'm not sure.
And then they also say the possibility of acoustically connected whales, which seem to be diving alone but are actually together, is mind-bending, they said. But they didn't have anything really referencing that up above. So this must be like a break in the article where they changed discussion topic.
Yeah, they do say down below here they talked about them diving in synchrony, but I agree that didn't seem to be the focal point
There's
up at
like
the
no
top.
transition. Yeah. So, surprising patterns of synchronized diving. The research team also made the surprising discovery of two bowhead whales diving in synchrony over the course of a week at a time, even when they were around 100 kilometers apart. The pair, one female and one of unknown sex, were sometimes as close as 5 kilometers and sometimes hundreds of kilometers apart. Yet they were closely timed their diving bouts for durations of up to a week, although to different depths. The synchronization was observed when they were within acoustic range of each other, which can exceed 100 kilometers, although the researchers didn't record the whales' sounds to determine whether they were interacting, as it remains a technically challenging task. Yeah, you need like military grade sonar, I think, to pick this stuff up. If something.
Well, and of course, that could actually interfere with it too.
See, I don't know. The hydrophones should be able to, right? Yeah, I just don't know. I think it would be pretty amazing. Because it isn't active, they're just listening. So maybe the possibility
I do
of
know, though, they'd have to be able to record on both sides, right? In some way.
Yeah, they definitely have to be able to record. Yeah, and if the sound is directional, then they wouldn't be able to get it from both angles unless they were sitting in the middle.
Okay, now whale 1, you sit over here, and whale 2, you sit over here. I'm going to be right in the middle now. Don't move.
Don't move. And the hydrophone would have to have stereo acoustics. They'd have to be able to listen in both directions. It seems like a really fascinating topic. The possibility of acoustically connected whales, which seem to be diving alone but are actually together, is mind-bending, is what they say again here. Pretty interesting. First evidence supporting the acoustic herd theory of long-range signaling in baleen whales proposed by Payne and Webb back in 1971. It's over 50 years
Wow.
ago.
I wonder if this is the first major advancement since then. I mean, that's a pretty big to-do.
Yeah. Must be. The argument is made in this article.
Yeah, it seems like they'd be referencing 2021 or something if there was something more recent.
Yeah. Time to put some really high-end microphones or listening devices in the water and see if they can pick up something really low frequency that can go a longer distance.
I'd love to see them record actual signals back and forth at those same times.
Yeah, I think it would be great. They say the main episodes of synchronization qualified by phase difference occur when the whales remain within the maximum acoustic range of approximately 130 kilometers. So the red and green shading indicates where the acoustic contact is likely or unlikely, but they didn't record, so they don't know if there was actually interaction.
But they noticed that the synchronization occurred when they were within a certain range of each other.
Yeah,
but they need to get that acoustic part to really, right now it's just correlative.
Yeah, so they both dove or both climbed at the same time within sonar range.
Right.
Yeah, fascinating. Let's keep hustling. The next article is over on Technology Today. New solar farms can benefit nature, and here's how. If you were told solar farms could take up to 0.3 of the total land area in the UK by 2035, would you take up a banner and march to Parliament and protest? It's hard to imagine anyone feeling troubled by such a perceptibly small figure. Well, Fabio Carvalho and Alona Armstrong from The Conversation put this article together for TechExplore.com. The Conversation has just massive input on Tech Explorer, at least when it comes to us aggregating.
They must have a significant partnership or something with them.
So instead, if you were told a solar farm the size of 960 football pitches was to be built outside your front door, would you join your local community to object it as loudly as possible, that's easier to imagine. Well, that's the NIMBY thing. Not in my backyard. Perceptions of scale and proximity aside, there is no shortage of opposing voices when the new Labour government approved 3 mega solar farms in the east of England last month. Together, they account for about 2/3 of the entire solar energy capacity installed in 2023. But solar farms don't just have to be about low carbon electricity. By the way, solar panels actually have a lot of toxicity, particularly in the recycling side of things. Hold on one second. Let me do. There you go, folks. If you want the show notes, !TT in chat, we'll do it. And they'll be posted over on YouTube as soon as I transfer everything over. The live stream is a different animal, but anyway. So it says their team's research on solar farms across the UK show that all these energy facilities can boost local pollinator populations and enhance pollination services to adjacent crops. For instance, managing solar farms as wildflower meadows can benefit bumblebee foraging and nesting, while larger farms can increase pollinator densities in surrounding landscapes compared to smaller sites managed as turf grass. Well, if you let natural flowers grow, then it makes sense that there's going to be more pollinators. So solar farms have been found to boost the diversity and abundance of certain plants, invertebrates, and birds compared to that on farmland if solar panels are integrated with vegetation, even in urban areas. So take that.
I mean, I can see why that is, right? There's nothing that's really interfering with nature, other than the solar panels themselves.
And those can actually provide periodic shade so that it's...
Right, exactly.
They gain some protection. So regardless of the potential benefits offered by the creation of wildlife habitats in and around solar farms, one common theme that emerges from most studies is the importance of locating, designing, and managing solar farms in a nature-friendly way. The design and management alone are unlikely to deliver all of the positive outcomes that could be possible from solar farm expansion. So they wanted to talk more about it. Appropriate public policies that link net zero targets with nature recovery could help ensure the solar farm could be managed to enhance biodiversity. And there is a recent study that they took part in. It says, in other words, the new government must roll out policies, and me making that statement on this is probably going to end up nixing my ability to promote the show. But what's funny is this doesn't have anything to do with the United States. It's about UK government.
Exactly. And really, this isn't, in my estimation, promoting any party. It's just promoting that we need to do something about this issue.
Yeah, and it's not just one place. It's the whole world needs to get on board with removing carbon from the atmosphere and going green and renewable overall. And a lot of houses have enough rooftop space that you can put solar panels on it. And then you have wind generation as well. Vertical wind farms instead of the giant windmill style. So it's just a cylinder, and in the right spot, wind can be amplified around like a corner of a building, and that can actually turn it's a wind tower. It's not a windmill.
Oh, okay.
It's not the big fan out on a hill. And it's largely local. So like each house would have one or more of these. Pardon me. Sorry for the coughing. Anyway. Yeah. And the article really is just, this is how it can benefit, but it's the green spaces between the solar farm. The only problem is when damage comes a knocking on a solar panel, or they have to upgrade a panel because it's lost its capability to produce power. They race over there with heavy equipment and damage all of the plants, but they grow back pretty quick. Most of the plants that could be growing there would be categorized as weeds.
Right, and I suspect that's better than not having the plants there to begin with. Yep. But they could also figure out ways to replace without destroying the habitat.
Heavy lift drones. I don't know. Something. Yeah. Humans have to come out there to do the work, though. until the robot overlords take over, or aliens. Moving on. Next article is over in Technology Today. Hearing temperature. Scientists uncover a new layer of human perception. Researchers have demonstrated that humans can perceive water temperature through sound, an ability likely developed through exposure, suggesting potential for new sensory brain maps and advanced. I don't know that we truncate the end of that, so I'll explain this because I've actually done this. And a research paper that was done by a member of a citizen of ohmTown actually exemplifies the difference between one sound and another based on the physical properties of the material. And that's exactly what this is going to be talking about. So Reichman University over at SciTech Daily, and I haven't even read this. I just know because I have experience with this. So basically, you can actually hear the difference between cold water and warm water because it actually drips at a different frequency. The sound it makes when it splashes.
Interesting.
Right? So let's see if my prediction is right. So researchers from Ivker Institute for Brain Cognition and Technology at Reichman University have uncovered a largely overlooked perceptual ability using machine learning to shed light on the dynamics of cross-modal perception, the interaction between different sensory modalities. In a study, the team explored whether humans can detect the thermal properties of water, such as its temperature, through its sound, and whether this perception occurs consciously. So, harnessing principles of multi-sensory integration, the team explored the potential of multisensory thermal perception. They also employed a pre-trained deep neural network, or DNN, and classification algorithm to examine whether machine learning could successfully and consistently classify audio recordings of water at different temperatures being poured and create a mapping of these thermal properties physically encoded in sound. So
this sounds exactly like what you were saying.
And I've actually demonstrated this about 10 years ago. So, but it wasn't in a science environment. It was in a more practical environment. I'll just say that. Or applied environment. So the question of whether multisensory perception of temperature extends to humans has been posed before. Previous studies have explored this on a behavioral level. These studies have shown that humans can hear a difference between hot liquids and cold liquids being poured, but not how or why this is possible. Yeah, because we can extrapolate from the data, which is the physics, the sound waves that are emitted by a cold drop are at a higher pitch because the molecules are closer together, whereas hot water is further apart, and thus the frequency is going to be lower. That is my estimation.
And I guess we might know that because we've somehow seen that we had cold water and heard it.
Correct.
Or we saw that it was hot water and heard it.
It's experiential. Yeah. So the researchers set out to first replicate previous findings and confirm this surprising perceptual ability, as well as clarify whether or not the ability is innate or acquired, a question that has long been the subject of much debate. It would be damn near impossible to deduce if a person has or has not heard cold versus warm water, because you may not be overtly aware of it, but your perception is there.
It seems like about the only way you could do it. You'd almost have to have an infant, which of course nobody's going to do a research experiment with an infant and having them touch hot water or something.
Yeah,
because then presumably they wouldn't have actually dealt with it.
Yeah, but I don't know how they can actually legitimately do this, because nobody is pure as the driven snow, literally, where they've never heard warm water. They've only heard tepid water. Which person, since they've been an infant, has never heard a bath being run? or a shower being turned on, and it slowly go from hot to cold, or cold to hot, or whatever. You instantly hear it, for crying out loud. So what we saw is that participants were consistently able to discern water temperature through its sound, even when they didn't believe that they could, which tells us that this is likely an implicit skill acquired through exposure to auditory cues throughout life. Yeah, I agree. Yeah, this Grant. Oh, God. Moving on. The next article is over in the Marvel Channel. Physicists throw world's smallest disco party with a levitating ball of fluorescent nanodiamond.
Okay, this is the second disco, but this one is the normal or well-known spelling disco. We had something else disco in one of the articles in this show.
Oh, Disco Elysium.
With a K.
Oh,
no,
disco?
In Technology Today.
Oh, we did?
Mm-hmm.
Really? Oh, really?
Mm-hmm.
Can my voice get any higher? So physicists at Purdue are throwing the world's smallest disco party. The disco ball itself is a fluorescent nanodiamond, which they have levitated and spun at incredibly high speeds. The fluorescent diamond emits and scatters multicolored lights in different directions as it rotates, and the party continues as they study the effects of fast rotation on the spin qubits within their system and are able to observe the Barry phase. Barry Manilow?
Maybe.
Purdue University. I want a grant because I want to get a PhD, and Purdue actually has the PhD that I want to pursue at Purdue. Get it? Pursue.
I gotta pursue
Anyway.
at Purdue.
Yeah. So yeah. So the team. Oh, wait. So what is the Barry phase? I haven't heard of that. I feel like I'm being punked, but we'll see. Arguably a groundbreaking moment in the study of rotating quantum systems and levitodynamics, or levitodynamics. So levitation dynamics, and a new milestone for the levitated optomechanics community. Imagine tiny diamonds floating in an empty space or vacuum. Inside these diamonds, there are spin qubits that scientists can use to make precise measurements and explore the mysterious relationship between quantum mechanics and gravity, explains Lee, who is also a member of the Purdue Quantum Science and Engineering Institute. What? How is there a quantum anything inside a diamond?
I have no idea.
Well, down the rabbit hole we go. The team made the diamonds rotate incredibly fast, up to 1.2 billion times per minute. By doing this, they were able to observe how the rotation affected the spin qubits in a unique way known as the Barry phase. This breakthrough helps us understand and study the fascinating world of quantum physics. They've said this like 3 times in this article.
Right.
But they haven't really moved this needle anywhere. The fluorescent nanodiamonds with an average diameter of about 750 nanometers were produced through high pressure, high temperature synthesis, so they're fake diamonds. These diamonds were irradiated with high energy electrons to create nitrogen vacancy color centers, which host electron spin qubits. How? How did they get an electron spin qubit?
I'm not really following anything in this experiment.
So, like a disco ball, as the nanodiamond rotated, the direction of scattered infrared light changed, carrying the rotation information of the nanodiamond. So it gave its location without it actually being sensed, which means that the qubit doesn't. So if something is spinning, then if you measure something for its location, you can't find out anything else about it. If you find out what its angular momentum is, you can't tell what its position is, but only where it's going. There's certain things where you can't, once you measure something, you can't find out anything else because you've basically disrupted the system.
Oh, okay. Because by doing so, you're interfering with it.
Correct.
Okay.
If I remember correctly, and I may be wrong. So like I said, I'm gonna end up going down the rabbit hole on this. So the authors of the paper were mostly from Purdue University and members of Lee's research group. Jin, who is the postdoc, subsequently performed measurements and calculations, and the team collectively discussed the results. For the design of our integrated surface ion trap, we used a commercial software, ComSol Multiphysics, to perform 3D simulations. So it's a simulation. We calculate the trapping position and microwave transmittance using different parameters to optimize the design. We added extra electrodes to conveniently control the motion of a levitated diamond. And for fabrication, the surface ion trap is fabricated on a sapphire wafer using photolithography. A 300 nanometer thick gold layer is deposited on the sapphire wafer to create the electrodes of the surface ion trap. So they basically saying that, which way are the diamonds spinning, and can they be speed and direction manipulated? Shen says yes, they can adjust the spin direction and levitation. We can adjust the driving voltage to change the spinning direction. The levitated diamond can rotate around the z-axis, which is perpendicular to the surface of the ion trap, which is up there. Let's see, either clockwise or counterclockwise, depending on our driving signal. If we don't apply the driving signal, the diamond will spin omnidirectionally like a ball of yarn. Okay. So, yeah, I don't know. It says general relativity and quantum mechanics are two of the most important scientific breakthroughs in the 20th century. However, we still don't know how gravity might be quantized. Achieving the ability to study quantum gravity experimentally would be a tremendous breakthrough. In addition, rotating diamonds with embedded spin qubits provide a platform to study the coupling between mechanical motion and quantum spins. Yeah, I'm going to end up lost in this if I allow myself. Because I'm really curious, like where they can take this. But
that's what I am too. I mean, they start to talk a little bit about application, like accelerometers and sensors, but
yeah, straight to using it in missiles. So, or rockets. I'll just say rockets. So I want to know about the qubit inside the diamond, because they just kind of throw that in there, like, oh, it's in there.
Right,
okay.
right.
How the hell did you get a qubit inside a spinning
exactly.
diamond? Yeah. Okay, let's move on, because like I said, I'll get lost in this. The next article is over in the Greenogram channel on ohmtown.com. Geology's biggest mystery: when did plate tectonics start to reshape the Earth? Grade school. Early grade school. So researchers have spent decades hunting for clues about the origins and the processes that move the continents. Hold on a second.
That music is kind of terrifying.
Yeah, I had to change it. So its deep history is finally starting to come into focus. I solved that problem when I was in grade school. Come on. We know all about plate tectonics. So,
I mean, not everybody is caught up with your research.
Yeah, really. Michael Marshall put this article together for nature.com. Researchers have spent decades hunting for clues about the origins of the process that moves the continents around. Its deep history is finally starting to come into focus. So yeah, it's kind of broken up, kind of like this puzzle. Some of it in the history of our existence, I should say the planet's existence, they've smashed into each other or pulled away from each other, and some are big and some are small, and you get massive mountains, or you get subduction zones and separation where it's massively deep, and an earthquake such as the ones that say in the Anatolian Peninsula cause great harm, and it's because the Earth's crust is divided into these shifting tectonic plates. So since the 60s, geoscientists have recognized the Earth's outer shell, the lithosphere, is not a single solid piece, but a series of rocky plates that jostle against each other and gradually change position. And over millennia, oceans widen and narrow and continents move around, which is what I got done saying. So when Earth formed 4.5 billion years ago, it was much hotter than today. The newborn Earth probably had a magma ocean rather than a solid surface. Perhaps something similar to Planet 55 Cancri E or Cancri. I'm not sure if that E is supposed to be separate or not. I don't remember. I think it is. Cancri E. Which had been studied by the James Webb Space Telescope. Eventually, the crust cooled, solidified, and then broke up into plates that began jostling against each other and migrating around the surface. The big question is, when did this all happen? So think about a big chunk of ice fracturing, and then in your glass, they're just all rubbing up against each other. Interestingly enough, even in your glass, the ice rubbing up against each other generates heat and causes the ice to melt.
Right.
So, I mean, it's, microscopic levels of heat generation, but any friction causes heat. So it says there's little hope of finding direct evidence from this period because most of the rocks formed in those early days have long been subducted into Earth's interior where they've melted and crushed. The Hadean eon from Earth's formation more than 4.5 billion years ago until 4 billion years ago is the most obscure of all. So there's no rock record from the Hadean.
That's interesting.
All that's left are tiny crystals called zircons, which you have to find, which are remnants of those Hadean rocks that later became incorporated into younger rocks, if the younger rocks survived. So the geological record of the subsequent Archean eon, which lasted between until 2.5 billion years ago, is better, but still fragmentary. Only about 5% of those rocks exposed at the surface today are Archean in age, says Dreeben. Pretty cool.
Yeah, I mean, I didn't realize this. I guess I kind of assumed rocks were available from the entire history of the planet, but it makes sense.
Yeah, I mean, they all get billions of years ago, there's a lot of churn between then and now. So they say in the past 10 years, however, a consensus has been emerging. A key transition seemed to happen around 3 billion years ago. Multiple lines of evidence indicate that the tectonic regime changed profoundly at this time. For example, a 2016 study found that the composition of the crust started to alter around 3 billion years ago. Older rocks were mafic. They contained lots of magnesium and iron and were dense. However, by 2.5 billion years ago, rocks were more felsic, meaning that they contained more silica and were less dense. The lower density meant that the plates could carry thick continents without sinking. Crucially, felsic rocks form only in the presence of water and heat. Today, these rocks are created in subduction zones, so the emergence of felsic rocks between 3 and 2.5 billion years ago implies subduction was underway. So they say it's well studied. Essentially, it started 4.5 to 4.4 billion years ago with a magma ocean and then cooled off to 3.8 billion years ago. Somewhere along the lines, water formed. Where did the water come from?
Yeah, that's not clear.
3.8 to 2.5 billion years ago, protoplate tectonics formed, where it was just a cooling off period where the magma hardened and continents formed and subduction zones were created, rift lines were created. And the rifts are actually where heat actually rises up and forces the plate to slide under in a subduction zone. We have those in various places on the planet. Plate tectonics formed 2.5 billion years ago to present. And this is the standard model of plate tectonics where a continent is sitting on top of the mantle, essentially. And the rift zone separates and gets pushed down underneath the continent. And sometimes there are mountains where it's the two butt up against each other and push each other up. And that's where you get mountain ranges. But they don't actually demonstrate that here, which is weird. Hold on a second. So why wouldn't they actually mention that?
I mean, maybe that's just beyond the scope of this particular study.
Yeah, I guess.
Because they were really trying to figure out when this started.
Right. Yeah, because they're basically demonstrating plate tectonics in the most fundamental level. Yeah. Okay. I'll just leave it alone because it's a convergent boundary, not subduction alone. So there's convergent, divergent, and transform boundaries where they slide against each other. But anyway.
Well, it's also possible the research paper went into more detail than this article.
Right on. Yeah, for sure. Okay. But everybody who has ever grown up anywhere at any time has written a plate tectonic paper as a child. So get on it, everybody.
I mean, it's a key thing to do in your education.
Yep.
And look, now you'll have more information to work with.
Yeah, way more than all us olds. So enjoy. Moving on. This next article is over in Technology Today as well. Juicier, glossier, better, faster, meaner, stronger, better.
Daft Punk.
Daft strawberries. Superior strawberries unlocked through genetics because that's what we want.
Bad bat.
Yeah, bad strawberry. When strawberries bite back. Next on. So I really don't have a problem with genetic modification, but we don't really know enough, and I don't really like being the beta tester. So unless I get a tail, if I get an opposable tail, I'm game. Sign me up. I don't want a sixth finger, although having an extra one to grab a doorknob while I'm carrying bags or something like that, that's really cool. Groundbreaking study has unveiled key genetic markers and candidate genes essential for improving the quality traits of strawberries, because we're doing important work there. Promising more vibrant, juicier, and longer lasting fruits. You know, I know, never mind. I was going to make a joke. Anyway, researchers from the University of Bordeaux have leveraged genome-wide association studies to advance our understanding of strawberry genetics, pinpointing 71 associations across 11 traits that influence fruit quality. You know what?
Mendel would be proud. Mendel would be proud. Kind of presumed to be like the father of genetics.
I swear to God, you said Mendel would be proud.
No, I said B-E.
I know, but because Mendel messed with peas.
But the pea plants, yeah.
I thought you were being punny. I would have to reboot your AI. So Nanjing Agricultural University, the Academy of Science, put the article together. It's posted over at scitechdaily.com. Look at that strawberry.
It looks like a good strawberry. I don't see any dents, dings, imperfections.
I know, the AI has dents and dings. So, I mean, I found the USB drive in the parking lot of Wendy's at 3 o'clock in the morning. Crying out loud. Anyway, you know what's really fascinating about this, though, is that Japan has like a fanatical following of certain strawberries that are like $20 a strawberry. I think they're actually like $8 a strawberry. They're like amazing, and they're big, and they're really juicy, and like strawberry flavor, like crazy and sweet.
So do you think this
will it rival it?
Right, I don't know, or accounts for it.
I don't know, but I think that they should focus on finding the sociopathic genetic associations with quality 71 genetic associations of sociopathic behavior and solve that damn problem, not strawberries. Anyway, breakthrough in strawberry.
Think how many people can eat strawberries.
Yeah, I know. Okay, so you've made a very valid point. You can't eat sociopaths. Thank you. I mean, you can when dystopia lands. Researchers from the University of Bordeaux have leveraged genome-wide association studies to advance our understanding of strawberry genetics. There was a breakthrough. Treasured for their flavor and health benefits, strawberries have been at the forefront of breeding programs targeting enhanced sensory and nutritional profiles, despite advances the intricate genetic makeup of these fruits. It's funny to say that. Has complicated efforts to improve them. So they've done some recent advancements in genetic research, particularly genome-wide association studies. They've proven new opportunities to explore and enhance these traits, and based on these challenges, there is a pressing need to conduct in-depth research on the genetic factors that influence fruit quality in strawberries, leveraging the rich Corinthian genetic diversity. No, sorry.
I don't think that's related to this study.
Corinthian leather? No, it's not. Anyway, they need to conduct in-depth research on the genetic factors that influence fruit quality in strawberries and the genetic diversity available in European strawberry varieties. Pretty interesting. So
how much do you think these strawberries will cost at the end of this?
$1 billion. I mean, it depends. If they leverage that, right, just give it out so everybody can make a better strawberry, then fine. It'll be cheap. But they're going to patent this process or whatever it is, and you're going to have this proprietary damn strawberry that gets seeded out everywhere. The findings from this study have substantial implications for strawberry breeding programs. By utilizing the newly identified genetic markers, breeders can more effectively select traits that enhance fruit quality, such as firmness and glossiness. This will not only improve the consumer experience, but also reduce post-harvest losses, contributing to more sustainable agricultural practices. I say hydroponics. Hydroponics all the way. But the only problem with hydroponics is that you don't get the free lunch of the sun.
Yeah, that's true. I don't know if it affects color of fruit, for example, like if you're doing indoor farming.
A full spectrum light should be fine.
That's true.
Yeah. It'll be expensive as hell, though. Like, quite a bit. Wish I could say more, but my process is proprietary. Of course, I don't sell anything that I make, but whatever. Moving on. Next article is over in Non Sequitur News. Simulations reveal clues to how breast cancer spreads. And it says in traditional mouse models that use breast cancer invasion, researchers take thin slices of tumor induced in a mouse and examine them under a microscope. And this procedure provides valuable information about breast cancer invasion, says Corey O'Hearn, senior author of the study, but it's limited in many ways. The problem with current mouse model studies is the histological studies only give a thin slice of the tumor at a single point in time. So they're coming up with a different way. Researchers are uncovering vital clues to how cancer cells invade breast tissue. The article is posted by Yale over at futurity.org. I don't know if you read on with this, but
I haven't read this one yet. I don't believe. I try to not read most of them in advance, but right. I'll announce if I do.
Gotcha. So they don't allow, these thin slices don't allow researchers to track the space-time evolution of cancer cell invasion, which is a problem that I have in business, because whenever you run a report, it's just a time slice. And so you have to keep on taking time
a snapshot or something.
Mm-hmm. Yeah. And too many, all you do is you see too many of a time slice, and if you don't do the holistic analysis, then you really don't know what's going on. And if you wait too long, then you have a snapshot over here and then a snapshot over here, and you don't know what the hell's going on in between. So you need the density, you need the vertical and the horizontal, and the trend and depth and breadth over time and space. And I think that's what their computational models are trying to determine, how cancer cells invade into breast tissue in 3 dimensions as a function of time. For example, we can predict how fast the cancer cells need to move a given distance through dense breast tissue, but it's really dependent on additional biological information. not all dense breast tissue has the same level of acceleration, because the genetics.
That's true. Different tumors can have different levels of aggression, I guess, for lack of a better term. And then also they can have different types, right? Like different types of cancers or variants, even on breast cancer.
Yeah. My understanding is it's essentially a metabolic function. So depending on how their biology is, it will either be aggressive or not aggressive, and the conflict with the type and the genetic makeup. Because if everything was normal, then the cells would die, but cancer cells don't. So who knows what's going on within that cancer type and that particular person's cancer. In addition to the computational models, the team is also developing in vitro experiments, model systems composed of micron-sized beads mixed with the collagen fibers that replicate many features of breast cancer in animal models and allow the computer simulation to be validated. O'Hearn led the computer simulations, while the in vitro experiments were conducted by Professor Claudia Fischbach of Cornell University. I find this really fascinating because they're creating an analog, so they don't even have to really test it on animals, and they can actually monitor in real time the in vitro
Which I like that.
Yep. So we're interested in understanding this process because the cancer cells invade the adipose tissue, the more likely they are to metastasize and form secondary tumors that are rarely curable. It's because they don't know that it's out there somewhere. That's the problem.
Right, until it's gone too far. Well, and really just when it spreads at all.
Right.
Because then it gets into the bloodstream.
Yep. So if the cancer cells were localized at the milk ducts, breast cancer would be much easier to treat, but it doesn't. It actually sends out. In the things that I have seen, it looks like it sends out little tendrils, and grows not in just a lump like dun dun dun. It actually kind of sends out a little arm and says, "I want to go over there." I think that's what they need to focus on. But I am not. Obviously, my area of expertise is not cancer research. So another factor is the size of the gaps between the fat cells and the extent to which the extracellular matrix within these gaps is aligned to enable efficient cancer cell migration. That is exactly what I just said. The tendrils follow a path, but I don't think anybody knows why they follow that path. And I think it's just the path of least resistance. It's kind of like electricity following, some conductor and it's usually ions that lead the arc of electricity to ground. I think that's basically what goes on here. And so do the cancer cells move ballistically or diffusively? Can they move fast enough to deform the adipocytes? If we understand these questions, we can understand the physical mechanisms by which cancer cells move through very dense adipose tissue. But they really shouldn't focus on just very dense. It just should be tissue. Because
true, but one of the areas where they have a difficult time
just detecting in
detecting, thank you, is in dense tissue.
Right.
So maybe that's why they're starting there. Mm-hmm.
Yeah, it just doesn't show up when they actually look, because dense material reflects at the same reflectivity as the cancer cells themselves.
Right, it obscures it.
Yep. So in the absence of tiny cameras that can observe breast cancer invasion in real time, O'Hearn says the two-prong approach of computer simulation and in vitro experiments may be the best approach. And I agree. I think that's just fine. But in time, I think a longitudinal analysis using a device that can monitor in all of those dimensions in that extracellular matrix embodiment, right? Scanning it constantly over a given period of time with a known aggressive cancer may be able to detect how it moves. But like I said, the images that I have been presented in the past show it as looking like a little tendril reaching out. And I've seen it in multiple over the years now, that it's this little tendril. And that's basically the spark that at least the doctors that I've spoken to have said that's really what in early onset, when they try and catch it fast, that's what they detect. So neat. And I hope that it leads to at least detection, because treatment is still basically wholesale. It's nuke it from orbit kind of a thing.
Right, exactly. And don't nuke it from orbit if you've already nuked it from orbit.
Yeah. Well,
if you have metastatic cancer, you can't get the same treatment as from the original, typically.
Ugh. Moving on. Quantum breakthrough in the coolest place on the space station, and that's probably where that tomato was found. The Cold Atom Lab on the International Space Station. Sorry.
There was a tomato that went missing for about a year, right, on the ISS?
Yeah, and they found it like behind a door somewhere.
Exactly. We reference it from time to time in the shows.
What's funny about it is that not only that, but like they're like, it smells like steak, burnt steak, but you have no sense of smell.
Well, they also thought one of the people on board had taken it something.
Yeah. You stole my tomato. But it had like rolled away. In that there's like mold on the space station. You want mold in space? For crying out loud. That's bad bat. Like interstellar bad bat. Anyway, the Cold Atom Lab in the International Space Station has made use of atom interferometry. I knew I wasn't going to mess it up, but for whatever reason, I just jammed up on the metry part of interferometry in space to detect environmental changes. Ugh. Georgina Torbet or Torbay, I don't know if they're like Colbert. Put the article together, digitaltrends.com. That's the Cold Atom Lab. I wish things weren't a nightmare of cables.
Yeah, why does it have to be so complex?
It's always buttons.
They need some cable
levers,
management there.
flashing and beeping, and just, it's insane. A modern car's engine compartment is somewhere in that nightmare of pipes and cables and crap is an engine. And somewhere behind this is the Cold Atom Lab. The only reason you know it says Cold Atom Lab is because it says it right there. Otherwise, oh, look, I found another tomato. Anyway, researchers employ a quantum tool called an atom interferometer, which uses atoms to measure forces like gravity. While these tools exist on Earth as well, on the planet's surface, there is Earth's gravity to deal with, which makes the instrument less sensitive. Oh, it needs a hug. In the microgravity environment of space, atoms can be measured for longer in a much more precise manner, and the researchers were able to use the instrument to detect the vibrations of the space station. So reaching this milestone was incredibly challenging, and our success was not always a given. It took dedication and a sense of adventure by the team to make this happen. I'm sorry.
I know.
They're making it sound like this.
The beginning of an adventure movie or something.
My goodness.
Or like a children's story or something.
Atom interferometry can be used to test Einstein's theory of general relativity in new ways, says lead researcher Cass Sackett of the University of Virginia. This is the basic theory explaining the large-scale structure of our universe, and we know that there are aspects of the theory that we don't understand correctly. This technology may help us fill in those gaps and give us a more complete picture of the reality we inhabit. I find it fascinating that Einstein's theory of general relativity is a metric by which aspects of the theory we don't understand is measured, even though the general theory of relativity has been it's written out. So how is it the general relativity? How is it the theory of general relativity in a documented form where people are pointing at it going, yes, it's still sound. Yes, it's still sound. When we don't even know what the it is that we're talking about.
Right. That's a good question.
I love fundamental research. It's just so much fun. And obviously, we don't know everything. And by we, I mean me. The sentient AI is from the future, so they know stuff, but they won't know
everything either.
And you won't tell us. So anyway, the technology is expected to have practical applications as well, such as improving navigation for aircraft and ships. They expect the space-based atom interferometry will lead to exciting new discoveries and fantastic quantum technologies impacting everyday life. My understanding is that the Cold Atom Lab is the building block of the quantum singularity that powers the time teleportation device that sent back the AI from the future.
Interesting.
Yeah, I've been looking at your code. Anyway, moving on. Next article, I've said too much, and I'll delete this from the log so you won't have any memory of it. The last article for Technology Today is over in Non Sequitur News. Scientists think that they've found the origin of the asteroid that wiped out the dinosaurs. It could help prevent a future mass extinction on Earth. Here's where
That's why we need that OSIRIS-REx type mission.
Yeah, that's right. And I just want to get out in front of this and say, I'm sorry for dropping the asteroid that wiped out the dinosaurs. So the asteroid that killed most dinosaurs 66 million years ago left behind traces of its own origin. Researchers think that they know where the Chicxulub impactor came from based on levels of ruthenium. Damn it, Ruth.
That's what I would have guessed.
Yeah, me too. Yep. You know what's funny about this is I have no idea what they're talking about.
But that makes it more interesting.
Like they're basically saying that they know what it was that wiped out the dinosaurs, but they don't know where it actually hit. They don't actually know what it was, right?
Exactly. But based on what it is, they can kind of go, okay, we can figure something out here.
But this is an actual impactor. It's not just some maybe of a thing. So team of researchers think they know the origin of a massive space rock that hit Earth and killed off almost all of the dinosaurs 66 million years ago. I'm a dinosaur, according to the kids. Didn't kill me off. Not yet. Jenny McGrath over at BusinessInsider.com put this article together. And here are some dinosaurs. Many experts agree an asteroid led to the extinction of the dinosaurs, but not the humans that used to ride those dinosaurs across the fields and plains of America 66 million years ago. That's right. Oh, yeah. 66 million years ago, humans and dinosaurs used to ride the plains together. We were buddies. And then a big-ass rock smashed down onto the planet. Anyway, their findings could help NASA in its search for potentially hazardous asteroids that pose a significant threat to life on Earth. I think humans pose a significant threat to life on Earth.
And that's true.
Some of them are as big as asteroids.
To dinosaurs.
You're a real asteroid. Not you, AI. You know who you are out there. So, to determine the dino-killing asteroid's origin, researchers pointed to the sky and said, out there.
Exactly. Accurate, but not very useful.
No, somebody that they really didn't like, somebody named Ruth, was the cause of it, because it says in particular they looked at the element ruthenium It's a rare element.
It's always Ruth.
It's either Karen or Ruth. So carinium was another one. It's a rare metal on Earth, but it's more abundant on asteroids. And ruthenium levels can be a good indicator of whether an asteroid originally formed in the outer solar system or the inner solar system. Mario Fisher-Gold, one of the researchers, told Business Insider. So thank you for talking with Business Insider. We appreciate it. Fisher-Gold and his colleagues found that unlike many other impactors over the last 541 million years, the Chicxulub impactor that killed the dinosaurs, and they're very adamant that that's the one that did it.
Yeah, I didn't know that was definitive.
And up to 75% of all life on Earth formed in the outer, not the inner solar system. So do you have an outer solar system or an innie?
I don't know what you're talking about.
I didn't know where you're going to take that, and I was actually afraid. So
I was afraid of that question.
Sometimes I'm afraid of the question. So NASA doesn't know where all the dangerous asteroids are. Again, depending on who you talk to, I'm one of the dangerous asteroids. So there are still many unknowns about these rocks, including where some of them are and which types may pose the most threat. So we're basically firing rockets at them and bouncing them. Well, it'll catch up to us later. Another 500
right?
million
Yeah,
years.
we'll figure out what happens later.
Hey, look, we have definitive proof that there was a massive impactor because we just caused one. Anyway,
several generations ago.
Yep. Their levels of ruthenium showed that most of the objects were S-type asteroids, which are found in the inner solar system. Meanwhile, samples taken from the Cretaceous Paleogene or KPG boundary, where the Chicxulub impactor hit, suggested that the object was a C-type asteroid, which typically live in the outer solar system. So something invaded our solar system and smashed into it. They actually crossed out. He said asteroids.
I've never seen this.
May have contributed to older mass extinction events like the one during the late Devonian period. Future research could explain the origins of asteroid strikes as well.
Is this like an article correction or something, and so it's intentionally marked? That is unusual.
Yeah, I've never seen that. Not without a note that explains what the strikeout is.
Right.
Fascinating. Huh. It's almost like somebody said the quiet part out loud.
Yeah, it's almost like they lined it out and then still published it or something. I don't know.
Hey, transparency. All right, folks. Well, thanks for the article. It's a lot of fun to read about this kind of stuff. But we are going to hop on our Devonian dinosaur, and we're going to stop by the only dinosaur that actually could speak.
Thesaurus.
The thesaurus, that's right. It had a huge vocabulary. Died out with that big-ass impactor. You don't want a big-ass impactor. Boom. We're back to Technology Today's front page. And this show decidedly turned a corner. So I'm going to blame it on caffeine. Maybe lack of sleep. It's only 8 o'clock. We have one more show. Or Will Tag talks about automotive technology. It's a fun show too. Come back and check it all out. But we're going to call Technology Today done and dusted. I am Mayor Watt. I run this whole kit and caboodle, and that's the visualizer for the sentient AI. Nope. Damn it. I'm never going to catch one of those neurons. Want to say bye?
Good night, hometown citizens. Thanks for joining us for Technology Today. We'll have another episode of that for you next week, but stay tuned for more shows.
See you later. Whoa, ruthenium. Good dinosaur.